Welcome to CLC Studios on top of Torpedo Towers. I'll be your host, Bill Coberts. We set out originally to do a 1-hour documentary on chloride channels and how they affect our daily lives. But unfortunately, as you'll find out, we could only dig up enough information to make up a 5-minute infomercial. Our starting point today starts off with a world-famous cation researcher who for some reason wishes to remain anonymous. So, Professor, why isn't anyone studying chloride channels?
Face it, chloride channels are boring. They are not involved in the action potential. They have wimpy voltage dependence, totally pathetic selectivity. Why bother?
Would you like to add anything else?
Well, the people who study them are just a bunch of nattering nabobs of negativism.
Thank you very much. Welcome back. With all that negativity, it's no wonder our famous researcher is attracted to cations. We didn't have much luck with him, so we decided to set out and hit the streets and really see what America knows about chloride channels. Can you tell me the most important ion channel in the human body? Is it a potassium channel, a calcium channel, a chloride channel, or a sodium channel?
I think it's potassium.
Do you think?
Chloride. It's chloride.
Chloride. All right.
Chloride. It's chloride.
All right. Okay, Robin. Of the following, which have CLC chloride channels?
Xenopus labius.
It's an apple.
Yes.
It should have them.
Okay. Tobacco.
It should have them too.
Potatoes.
Yes.
Marshmallows.
Not living, no.
E. coli.
It's a living organism, so I must have them.
Okay. And humans.
No, we don't. No.
Excellent. Gina, do you think the government is spending enough money on chloride channel research?
Sure.
Sure. Okay. Second question we want to ask you is, should major universities hire aspiring young faculty who study CLC chloride channels?
Yes.
Thank you very much.
You're welcome.
It's apparent that from the everyday American that they have this feeling that CLC channels are important. We next set out to do some serious investigative reporting to find out more about these exciting channels. We're here in the library in the reference section. We're trying to find out more about chloride channels since our experts and our public haven't really helped us too much. So let's see what we can find. Oh, this looks very interesting and very informative. Well, that's cation channels. That's quite a large book. Let's see if we can find something on chloride channels. Oh, it seems like we have something here. Chloride channels. A reference manual. Let's see what it says. Chloride channels, clearly they're important. And defects in chloride channels give rise to myotonia, dense disease, and Bartter syndrome. Wow, Bartter syndrome. That sounds bad. Well, we need to find out more about this, so let's take a break and we'll get back to you in a few. Time for another shot of penicillin, Rob?
No, Bill. This time, it's the kidney stones.
Ah, that wretched dense disease.
Damn, if only my chloride channels function normally.
I hear you. Welcome back. We're here at the Volin Center for Complicated Systems, and we've heard that chloride channel research does in fact go on here. And so we decided to go around and look at a few of the labs and see what types of research are happening. Follow me. Wow, this looks quite promising. Shall we go inside? Professor, what types of research? Oh, sorry. Are you busy? Can we talk?
No, that's okay.
All right. What type of research do you do in this lab here? The sign outside seemed quite interesting.
Well, we work on chloride channel structure and function, and you know that they're very important for muscles and excitability of skeletal muscle. Actually, you may have heard of these myotonic goats. Al George has talked about it a lot. He showed nice pictures.
Where you can clap.
You clap, you startle them, and they fall down. They go into myotonia, and they can't get up.
We've read about that here at Investigative
Well, we've
Reports.
expanded that. We're extending that to graduate students. We've made some myotonic graduate students.
So if I clap, they'll fall over?
No, that doesn't startle them. Oh, but let me show you something that does.
Excellent.
Just a minute. Guys, we got some bad news. The grant got triaged, and there's not going to be any more stipend for you.
Wow, that's great. Did you get that? Unbelievable. Now, will they get back up like the goats?
Oh, eventually they will.
Oh,
yeah,
okay.
Yeah.
How about Barter syndrome? Have you ever heard of it?
Barter syndrome. Barters?
Barter.
Oh, yeah. Doesn't that have something to do with potassium channels?
I don't think so. I'm sorry.
No.
Well,
No.
well, thank you very much. That was very. Well, that was pretty amazing. We've already been in the Volin Center for 5 minutes, and we've run into 2 well-known chloride channel diseases. But we still haven't really figured out about Barter syndrome. What is it? Who has it? Let's go around to the other labs in the Volin Center and try to figure out what this syndrome is. Follow me. Dan Oprian, do you know what Barter syndrome is?
Well, that causes excessive flatulence, doesn't it?
Thank you. Tim Strassmeyer, what can you tell me about Barter syndrome?
Barter syndrome? What, it's terrible. Every graduate student I know has it.
Thank you very much. Jeff Gellis, do you know what Barter syndrome is?
Isn't that what President Clinton has?
Actually, I think that's bachelor syndrome, but thank you. We didn't seem to have too much luck here at the Volin Center trying to find out about Barter syndrome. So I'm going to take some advice from an old advisor who once said, if things don't work in the lab, hit the pub. We'll see you there. Hey Rob, how's it going?
All right, Billy, how you doing there, buddy? What can I get you today?
How about a Miller Genuine Draft?
You still drinking that Miller? I think it's kind of a light beer, you know? Why don't I pour you some with a little bit more structure to it? Say a McKinnon ale.
Actually, on second thought, why don't I go for a double-barrel shotgun?
Whew, the double barrel, huh? Must have had a rough day today, Billy.
Yeah, I've been spending 12 hours trying to do this documentary on chloride channels. Nobody knows anything. Nobody cares. Spent 3.5 hours in the library trying to find out about Barter syndrome.
Huh. Barter syndrome. I think you're talking your autosomal recessive salt wasting nephropathy there. I think it's due to abnormal sodium chloride reabsorption in the thick ascending limb. I'm thinking chloride channel defect, and you know, I think it's a CLC that's the problem.
How do you know so much about chloride channels?
I'll tell you, Billy, I don't really know that much about chloride channels, but you know something? No one really knows that much about chloride channels these days. I mean, talk about transmembrane topology, right? They got 10 transmembrane segments. They got 12. Who knows? Either one could be the case. And then, I'll tell you, at least we know that the C-terminus is on the inside. But we think they're double-barreled homodimers, but you know what? We're not really sure. Then you got this thing where chloride, right, the Permian ion, acts like the gating charge. You know, not to mention the fact that the gating violates microscopic reversibility. I'm telling you, it's enough to make a guy want to go back and just study Gramocidin.
Whew. Well, here's to studying CLC channels.
All right.